polynomials, linear factors, and zeros. At the end of this video, you should be able to do two different things. Be able to analyze the factored form of a polynomial, and if you're given the zeros of a polynomial, be able to write the polynomial. When you're analyzing polynomials that are factored, you can just get a lot of information from a couple basic things that you see. For example, if x minus b is a factor, then we can find out all sorts of stuff using the number b, where b can be any number. There's four basic statements that all mean the same thing. So again, x minus b is going to be our factor. It could be x minus 3, it could be x plus 5, whatever. But x minus b is a factor. B is also a zero of the main polynomial. B is also a root of the polynomial. And if you were to graph the polynomial, b is one of the x-intercepts. There's just a couple main concepts of this video. One of them is to realize that if x minus b is a factor, then b is a zero of the related function, or a zero of the graph. And the opposite is true. If b is a zero of the function, then x minus b must be a factor. So if you can see a graph and see a zero, you can figure out what one of the factors are really simple. New term, multiplicity. If you factor something, a polynomial, and you have the same factor show up twice, let's say you have x minus 2 times x minus 2. Well then 2 is a zero of the polynomial, and 2 has a multiplicity of 2 because it showed up twice. Now if something has a multiplicity of 1 and you're looking at the graph is linear at that spot. But if a zero has a multiplicity of 2 and you're looking at the graph at that zero, then the graph is going to look like a little parabola or a little quadratic function at that location. Likewise, back when the multiplicity was 1, the graph looked linear or aligned at that location. But if the multiplicity is 3, you have the same three factors, x plus 3 times x plus 3 times x plus 3, then at the zero of negative 3, the graph is going to look cubic at that location. Not linear, not parabolic, but cubic. And so on and so on. As the multiplicity increases, the picture changes. Factoring. We need to be able to factor. If there's a GCF, factor it out. Always remember that. First step in factoring, take out the GCF. Once you factor out the GCF, whatever polynomial is left, continue factoring that until it's completely factored. And then you can analyze it using the stuff that we're learning today. Okay, here's a couple examples. What are the zeros of this polynomial? You have x plus 2 times x minus 1 times x minus 3, and then graph the function. I want you to think about that, see if you can come up with it before we discuss it. Can you think about how to graph it also? Okay, finding the zeros, real simple. We already learned this with quadratic, the zero product property. If x plus 2 times x minus 1 times x minus 3 equals 0, what do you know about each of the three factors, or one of the three factors, to get 0? That's right. Each factor could possibly be 0. So x plus 2 could be 0, or x minus 1 is equal to 0, or x minus 3 is equal to 0. Solve those three equations, and now you know the three zeros, -2, +1, and +3, from that original polynomial of x plus 2, x minus 1 times x minus 3. Now, to graph it, find some other points besides the zeros. You know -2, 1, and 3 are zeros, so find some points in between those points, like when x is -1 or 0, or like when x is 2. How can you find those points? You just plug in the numbers that you pick. Now again, -1, 0, and 2 are not the zeros, they're numbers in between the zeros. So it's other points besides the zeros that we can graph. Have you evaluated what the y values are? There they are. So when x is -1, we get 8 for y. When x is 0, we get 6 for y. And when x is 2, we get -4 for y. Now we have 3 more points that we can graph, besides the 3 zeros, which we already figured out. What's the end behavior of this polynomial? We have 3 factors being multiplied together. They each have an x. What are the end behaviors? X times x times x. That gives us an x cubed function. It's a cubic function. And it's +1, +1, +1 for each of the coefficients, so the final coefficient's positive. So we have an odd exponent, x cubed, with a positive coefficient. So the end behaviors are down and up, just like a line that has a positive slope, because it has an odd exponent. Now we're able to start graphing. We know our 3 zeros, we know 3 more points, we know the end behaviors. So we need to grab a piece of graph paper and graph. First step in graphing, just graph the 3 zeros, -2, 1, and 3. 3 simple dots. Then we should probably graph the other 3 dots that we figured out. -1, 8, 0, 6, and 2, -4. So now we have 3 additional dots. Looks like quite a mess in the graph paper, a bunch of random dots. How are we going to graph this now? What was the other thing we figured out? Oh yeah, end behaviors. It goes from down to up. That means at the beginning of the graph, or the left-hand side of the graph is down. And at the ending of the graph, if you're graphing from left to right, it's the ending. The right-hand side of the graph, it goes upwards. So we need to start drawing a smooth curve from down, go up through the dots, back down through the 0, and back up. And that's what end behavior means, down, up. It starts down on the left and up on the right, and we have a beautiful graph of a cubic function. All starting from the zeros. Okay, another one. Write a polynomial function in standard form when given some zeros. In this case, -2, +2, and 3. How are we going to do this? Given the zeros. So where do we go from here? Think about that. What do they tell us? Factors. If -2 is a 0, then x plus 2 is a factor. If +2 and +3 are zeros, then x minus 2 and x minus 3 are factors. I have 3 factors, you multiply the 3 together. There's our function, but it's not in standard form. So to get it into standard form, you multiply the factors together. X plus 2 times x minus 2 is x squared minus 4. I didn't forget the middle term, the x term, because it cancels out. This is a difference of 2 squares. So be careful when you're multiplying. Make sure you FOIL it or distribute the polynomials correctly. Now x squared minus 4 times x minus 3, if you multiply that out, distribute it, you end up with x cubed minus 3x squared minus 4x plus 12, a polynomial in standard form, given the zeros, negative 2, positive 2, and positive 3 at the beginning of the problem. So make sure you go all the way to standard form.